Okay, so this question has to do with Ampere's law. And we can see that right here, the closed loop integral of b dot ds. So I'm just going to write Ampere's law, b dot ds is equal to mu naught I enclosed. So that's enclosed just means the current inside. And so when they say, I feel like a lot of students aren't really sure what they're asking. They're not asking you to solve for the B field, which is often what they ask for. They're asking you to solve for the left side of the equation. So they want you to give them an answer to what is the right side. And so the key to understanding this is knowing that this is my Amperian loop, right? So this is my Amperian loop. And so what I want is the I enclosed is what's enclosed by the Amperian loop. And so I do know that this is the cross section. So like this is a thick wire coming in and out of the page, right? And this is like I'm looking at it on cross section, and I know that this wire carries the full current I. So I'm not getting the full current I. I'm getting some part of it. So I have to think about current density. And so if we remember that current density J has units of amps per area. And so J is equal to the current, so that's going to be I over area. And in our case, the area is going to be the area we're thinking about inside my Amperian loop is going to be pi r squared. So so I know that that I want to plug in I. So that tells me that I is equal to J times pi r squared. And I can plug that in here. So I know that I'm just going to put equals mu naught J times pi r squared. Now if I look down at my answers, though, all of my answers are in terms of I, not in terms of J. So I can think about current density again, and I know that that J is equal to I over pi big R squared. So so this gives me I enclosed, right? I have some current density and I need to multiply it by an area. I can also take my current density and I have I, and I can do it by my full area. So I can now substitute this J. I can substitute I over pi r squared for that J. So that's going to equal mu naught I, let's see if I can erase that. Oh, I can. I over pi r squared. Just plugging that in over there. And then times pi little r squared. My pi's cancel. So mu naught I little r squared over big R squared. So I'm going to have the answer is D.